Hello my dear friends, today we will be studying about the image charge, the concept of an image charge. Suppose we have a conducting plane, okay, there is a conducting plane which is earthed, so its potential is 0 volt. Now I keep a point charge plus q at the point A which is at a distance d from this conducting plane. So definitely this point charge will induce some opposite charge on this conducting plane, right? Now that induced charge, we can imagine that as if that induced charge is minus q and it is kept at an equal distance on the other side of the conducting plane, that is at the point B, okay? As if the conducting plane is behaving like a plane mirror and the image of this charge appears here, okay? So this minus q, which is the induced charge, is imagined to be the image of charge plus q and this placed here, which is at an equal distance from the conducting plane. Now if I want to find out electric field at the point P, which is at a distance smaller from the point A, so AP is smaller, the angle made by AP with the positive direction of x-axis is theta, so I can specify the coordinate of the point P as r comma theta. This is a representation of plane polar coordinate. So there will be two electric fields. One is ER, which is the radial component of electric field, and another one is E theta, which is the tangential component of electric field. ER and E theta are mutually perpendicular to each other, okay? If this angle is theta, this is theta, so component of ER in that direction, ER cos theta, and this angle between ER and E theta is 90 degree, so definitely by simple geometry you can understand that the component of E theta in this direction is, it has to be E theta sin theta. Fine. CA, that is C is any point on this conducting plane. Let me tell you, this conducting plane is of infinite extent. It is an infinitely long conducting plane. So any point on the conducting plane is at a distance capital R from A as well as from B. So it is like a perpendicular bisector of the line segment AB. Okay. So I want to find out at first what is the electrostatic potential at the point P. But before that, I must find out what is the distance BP. So please see, distance BP is equals to this distance square plus this distance square. So r square plus 4d square minus 2r into 2d cos of the angle between them. So this is theta, this total angle is 180 minus theta. So cos pi minus theta. So it is nothing but r square plus 4d square plus 4rd cos theta. This is the distance BP. So therefore potential at the point P is 1 by 4 pi epsilon 0. I can take q by 4 pi epsilon 0. Here is a positive charge, so 1 by r. And here is a negative charge, so minus 1 divided by this distance. Okay, so this is to the power half. To the power half. So it is r square plus 4d square plus 4rd cos theta raised to the power half. Once you get the potential, then we can find out the electric field. So therefore radial component of electric field is minus del Vp del R. Now why I am using partial differential sign? Because you see this potential at the point P is a function of R as well as theta. So there are two variable dependencies, so that's why del. So what we can write here, minus q by 4 pi epsilon naught. If you differentiate 1 by r, you get minus 1 by r square. Then minus 1 by, if you differentiate 1 by x to the power half, you please see ddx of x to the power minus half will give you minus half x to the power minus 3 by 2. So that is minus 1 by 2 into x to the power 3 by 2, right? So if you differentiate this, so you will get a minus sign, that minus sign will make this one plus, okay? And then you will get 2 into this to the power 3 by 2. So r square plus 4d square plus 4rd cos theta to the power 3 by 2. Now differentiate this. If you differentiate this with respect to r, so 2r plus 4d cos theta. Okay. Now once you do this, then this 2 you can take 2 common from here. So 2 and this 2 cancels. So from here you get er equals to, you bring this minus sign inside, so q by 4 pi epsilon 0 1 by r square minus r plus 2d cos theta divided by r square plus 4d square plus 4rd cos theta raised to the power 3 by 2. Okay, so this is the radial component of electric field. I can write this one as my equation 1, this is my equation 2. Now if I want to find out the tangential component of electric field, E theta equals to minus 1 by r del Vp del theta. So I can write it like this, minus 1 by r del theta of this thing. So minus q by 4 pi epsilon 0 small r, and del theta of this one, the first term is 0 because there is no theta dependence. Then if you do the second term, so you have here a minus sign is there, so again it will follow this procedure, so this will become plus, and then you will get 1 by 2 x to the power 3 by 2 means r square plus 4d square plus 4rd cos theta to the power 3 by 2. Differentiate what is inside. If you differentiate with respect to theta, so here you will get minus 4rd sin theta. That's all that you will get. So this minus and this minus will make it plus. Okay, you can cancel 1 2 here and you can cancel the r here. So basically this is E theta. So therefore let me write it properly. So E theta equals to 2qd sin theta by 4 pi epsilon 0 r square plus 4d square plus 4rd cos theta raised to the power 3 by 2. Okay, so this is my equation 3. Once I have got ER and E theta, I can find out the net electric field at the point P along the positive x direction. Okay, so once you know what is the electric field along x direction, ER cos theta I cap plus E theta sin theta minus I cap. So net field along x direction is ER cos theta minus E theta sin theta. Okay, so I have to rub certain parts. So please see, E at the point P along x direction, that is equals to ER cosine theta minus E theta sin theta. So if you do that, ER cosine theta, ER is this one, so multiplied by cos theta, so q by 4 pi epsilon 0. See, this one also has, this one also has, so I am taking it common, q by 4 pi epsilon 0 cos theta by r square minus multiply by cos theta, so you get r cos theta plus 2d cos square theta by r square plus 4d square plus 4rd cos theta to the power 3 by 2. Okay, minus E theta sin theta. So minus E theta is this sin theta, so multiplied with sin theta, q by 4 pi epsilon 0 is already outside, so you get 2d sin square theta by r square plus 4d square plus 4rd cos theta raised to the power 3 by 2. Okay, so this is exactly how you get EP at the point P along x direction. This is the expression. Okay, Now once you have got this, now we can simplify this. So this is equals to q by 4 pi epsilon naught cos theta by r square. You can take minus common and you can add these two. If you add these two minus common, then you get r square plus 4d square plus 4rd cos theta raised to the power 3 by 2. Okay, you take minus common, now you add, so you get r cos theta plus 2d cos square theta plus 2d sin square theta, so you get 2d. So this is your expression for electric field at the point x, at the point P along the x direction, right? Now once you get this one, if I shift the point P to the point C, suppose this line AP shifts to AC, so if I want to find out the net electric field which is perpendicular to this infinitely long plane which is an earth surface, what is the electric field in a direction perpendicular to the plane, then I have to shift the line AP on AC. So when AP is equals to AC, okay, that means, or rather we should write like this, at the point C, at C. If you come to the point C, then what assumption can it be? So small r will become capital R. So we can write small r equals to capital R. And you see cos phi is d by r. As phi equals to pi minus theta, so therefore cos theta equals to minus d by r. Now you implement these two assumptions here. So therefore ENC, what is ENC? Normal component of electric field at the point C, because the net field will be this and it is perpendicular to the plane. So normal component of electric field at the point C, if you put the values, you get q by 4 pi epsilon naught cos theta by r square. Cos theta is minus d by r, so minus d by r divided by r square minus r cos theta, so I can write r into cos theta minus d by r plus 2d divided by r square plus 4d square plus 4 capital R d minus d by r, and this whole thing raised to the power 3 by 2, right? Now when you do this, you please see from here what you will get. You will get minus d by r cube. Here r cancels, so minus d plus 2d. So from here you will get d. And here what you are getting? This. You are getting this one. This r cancels. So minus 4d square plus 4d square vanishes. Okay. So on numerator you have d, and denominator you have r square to the power 3 by 2 means d by r cube. So you get d by r cube here, here also minus d by r cube. So minus d by r cube minus d by r cube. So minus 2d by r cube. So basically you get minus 2qd by 4 pi epsilon naught r cube. So this is the normal component of electric field at the point C. Okay, very important expression. What is the normal component of electric field at the point C? We found out. Okay. Please take a screenshot of this. Now you see, once we have arrived here, we can find out the surface charge density at the point C. So surface charge density, see this plus q is inducing some charge on this infinite plane. And on each and every point on this plane, the value of surface charge density is actually varying. We will just see that. So how do we find surface charge density? We write electric field equal to sigma by epsilon 0. Now what is that electric field? That electric field is normal component of electric field, or the electric field which is perpendicular to the surface at that point. Okay, so we found out the normal component of electric field at the point C, and this is the expression. So how we can find out sigma? So we can write therefore ENC equal to sigma by epsilon 0, or sigma equals to epsilon naught E normal component. So sigma equals to, if you multiply epsilon 0 with ENC, you are left with minus 2qd divided by 4 pi epsilon 0 r cube. Very clearly you can see that sigma is proportional to 1 by r cube. Okay, sigma is proportional to 1 by r cube. So as capital R increases, value of sigma decreases. Where is the value of sigma maximum? Value of sigma is maximum at the point O, where the value of capital R is D. So if you take the point C, instead of the point C you take the point O, this R will become D. You can put D here, and then you will get the maximum value of sigma at the point O. Another interesting thing, that sigma is negative. Why sigma is negative? Because the induced charge is negative. Is it not supposed to be negative? Yes. So we got correct result. So this is the surface charge density at the point C. Now if you go to different points, this value shall vary. Okay, now let us find out the total charge which is induced on this infinite plane. See very carefully, it's very interesting concept. So if this is the plane, okay, if this is the plane, on the plane you consider this is plus q charge. On the plane at the point C, suppose this point is C and this distance is capital R, this is capital L, right? So of radius capital L you consider a ring. You consider a ring on the plane. On this plane you consider a ring. So that ring has radius L and it also has a small thickness. There is an elementary ring, and what is the thickness? The thickness is dl. Thickness is dl. So how much charge is actually present in this area? Sigma is surface charge density. So I can write dq. What can be written, you please see? I can write dq induced is equals to 2 pi L dl into sigma. Now you can very easily see that L square plus d square is r square. L square plus d square equals to r square. D is fixed. Now you can differentiate. If you differentiate, you get L dl equals to r dr. Actually you get 2r dr, 2l dl, to 2 cancels. Now you can put it here. So dq induced equals to 2 pi r dr into sigma. Sigma is this, minus 2qd by 4 pi epsilon 0 r cube. Okay, once you do this, 2 pi and 4 pi you cancel, so you get 2. You cancel this 2 with this 2. Okay, cancel 1 r and here you get r square. So basically what you are getting, so dq induced equals to minus qd dr by r square. Okay, so basically this epsilon naught is not here because you multiplied with epsilon, so 4 pi r cube. So this is not there, 4 pi r cube. Now minus qd into dr by r square, that's what you got. Now if you you integrate q to q induced, total charge which is induced here, and here r shall vary. So you have to, what is the minimum value of r? D, and when you go to infinity the value of r is infinity. So d to infinity you integrate. So you get q induced equals to minus qd. If you integrate this you get minus 1 by r running from d to infinity, minus 1 by infinity plus 1 by d. 1 by d and d cancels, so you get q induced. See how beautiful the concept is. So this is the total charge which is induced on this infinitely long plane, and all the induced charge is distributed on this infinitely long plane, and we are considering very rightly that the induced charge is minus q. So this value of induced charge minus q has been proved here. So this is definitely correct. Now next thing that we have to prove is the distance which we have taken on the other side of the plane. Is it really d? That's what we will see. For that we will find out how much force is experienced by this charge q because of this ring which is taken on this plane. Okay, so this is another very important conclusion that we have drawn. Now let us find out the force which the point charge plus q experiences at the point A. Please take a screenshot. So please see, this ring that I have considered, this ring it has some negative charge. Of course it has some negative charge. So the negative charge will basically attract q. So this q, because of this infinitesimal ring or a ring of infinitesimal thickness, will experience some force, say dF. It will experience dF. If that angle is phi, if this angle is phi, so in this direction what force will act? dF cos phi, and this direction dF sin phi, right? Similarly, there is a corresponding part here. If you consider this particular part, so similarly in this direction there will be dF, in this direction again dF cos phi, and in this direction dF sin phi. So please see, for any two corresponding or diametrically opposite parts, dF sin phi cancels and dF cos phi gets added up. Okay, so for all the parts on this ring, all dF cos phi shall get added up. So what is the net force? Net force is nothing but, I can call it dfx, is dF cos phi. And what is dF? 1 by 4 pi epsilon 0 q1 q2 by r square. So this is q. What is the charge enclosed by the ring? 2 pi L dl into sigma divided by the distance square. What is the distance? This is the distance. This distance is capital R. So by capital R square multiplied by cos phi. What is cos phi? Cos phi is base by hypotenuse, so d by r. Okay, so it comes as d by r. So now let me sort things out. So 1 by 4 pi epsilon 0. Now instead of LDL I can write r dr. Just few minutes back I showed you. So it is 2 pi q r dr by r cube into d into sigma. Sigma is minus 2qd divided by 4 pi r cube. Okay, so you see 2 pi, so it cancels 2 here, this 2 cancels with this 2. Now you see this is r here, so r, so it becomes r square. So basically what you are getting, q square d square by 4 pi epsilon 0 into dr. Okay, there is a negative sign, by r to the power 5. So if you want to find out the net force Fx, so all you got to do is integrate. So integrate from where? Same limit, r should be d to infinity. So d to infinity. Now if you integrate that, what will you get? So Fx equals to minus q square d square by 4 pi epsilon 0 dr by r to the power 5 will be what? R to the power minus 5 plus 1 by minus 5 plus 1. Okay, so basically what we are getting, d to infinity. So this one is nothing but r to the power minus 4, means if you put the upper limit, value vanishes, lower limit if you put the value, So you get 0 minus minus of this, so plus, and here you get 4 d to the power 4. So minus q square d square by 4 pi epsilon 0 into 1 by 4 d to the power 4. Now cancel here. So basically you are getting minus q square by 4 pi epsilon 0 2d whole square. This is the force that you have got. Minus q square by 4 pi epsilon 0 2d whole square. Now please see very carefully. What is the force between B and A? 1 by 4 pi epsilon 0 q1 q2 by r square. So if you multiply q and q, so it is q square, and what is the distance? 2d whole square. See here you are getting 2d whole square. So that means our previous assumption that the image charge can be kept at a distance d on the other side of the plane is absolutely correct. Why negative? Because the force is attractive force and it is directed along the negative x direction. So that's why that minus sign has appeared here. Okay, so it's a very beautiful concept which illustrates that this arched infinite plane of charge behaves as if it is a plane mirror, and the positive point charge and the image charge, they are at equal distance from each other from that plane surface. Okay, so this is acting like a mirror and this is acting as a virtual image of this real object. So that is basically the beauty of physics. You see, nature loves symmetry, and this symmetry repeats itself. You may not have thought that in this particular analysis which we studied, that this infinitely long plane of charge, the infinitely long earth plane surface is acting like a mirror. So you studied mirror in geometrical optics, right? And here we are studying electrostatics. So see, in nature these symmetries repeat itself. They are connected by a very beautiful thread. All the concepts are connected by a very beautiful thread. Once we identify that thread, then we know nature, right? And things become very easy in that case. So this method of imaging, it is not quite taught at the class 2 level, but this gives you a very interesting insight into electrostatics. I hope this discussion was helpful to you. Thank you so much.